Welcome to this course on engineering economics and materials. Engineering is not only about designing machines, structures, or systems. It is also about making decisions that involve money, time, effort, and materials. Every project, whether building a bridge, launching a new product, or developing a renewable energy plant, involves allocating scarce resources among competing alternatives. This course equips you with two essential skill sets. Engineering economics, the ability to evaluate cost and benefits, compare alternatives, and make rational decisions in projects and investments. Engineering materials, the knowledge of material selection, behavior, and life cycle, which directly affects cost, safety, performance, and sustainability of engineering designs. We will divide the course into two modules. Module 1, Engineering Economics, Principles, Decision-Making Frameworks, and Evaluation of Engineering Projects. Module 2, Engineering Materials, Selection, Life Cycle, and Economic Implications. Let's begin with Module 1. Module 1, Engineering Economics. 1.1 Understanding Engineering Economy. At its core, engineering economy is the process of making well-informed decisions when resources are scarce and alternatives are available. It provides structured methods to determine the most beneficial use of money, time, and materials. The central question is, which option delivers the greatest value for the least cost, while meeting performance and safety requirements? Engineers often face decisions such as: should we build a new plant or upgrade the existing one? Is solar energy more cost-effective than diesel power over the long run? Which product design should be selected given budget constraints? Engineering economics helps answer these questions by balancing technical feasibility with financial practicality. 1.2 Key Principles of Engineering Economy. Several guiding principles shape engineering economic decisions. Scarcity of resources. Resources such as money, materials, and time are limited. Choices must therefore prioritize efficiency. Alternatives exist. Almost every decision has multiple possible approaches. Comparative evaluation. Alternatives must be compared on a consistent basis, usually in terms of cost, benefit, and risk. Time value of money. $1 today is worth more than $1 tomorrow. Timing of cash flows matters. Uncertainty and risk. Future conditions, such as market demand, inflation, or technology changes, add risk to decisions. 1.3 Applications of engineering economics. Engineering economics is widely applied across industries. Examples include product development, deciding whether to design a new product, modify an existing one, or license technology. Capital purchases, choosing machines, software systems, or equipment that balance performance with cost. Infrastructure projects, evaluating whether to build highways, power plants, or telecommunication networks. Technology management, deciding when to adopt, upgrade, or replace technologies across their life cycles. Sustainability planning, weighing the cost and benefits of eco-friendly materials or renewable energy solutions. 1.4 The decision-making framework. When making economic decisions, engineers often follow a structured process. Define the problem, clearly state the objective and identify constraints. Identify alternatives, list feasible options for solving the problem. Evaluate alternatives, compare cost, benefits, risks, and non-financial factors. Select the best alternative, choose the option that maximizes overall value. Implement and monitor, put the decision into practice and track results. This framework ensures decisions are rational, transparent, and defensible. 1.5 Evaluating cost and benefits. One of the most important tasks is to evaluate cost and benefits. These include initial cost, purchase, installation, and startup expenses. Operating cost, energy, maintenance, labor, and consumables. Salvage value, remaining value at the end of useful life. Intangible benefits, improved safety, reduced emissions, or enhanced brand reputation. By quantifying and comparing these elements, engineers can identify the most economical option. 1.6 Lifecycle perspective. Engineering decisions are not only about immediate cost. They must consider the entire lifecycle of a project or product. This includes research and development, design and prototyping, production and operation, maintenance and support, disposal or recycling. A short-term saving that increases maintenance cost over the long run may not be economical overall. 1.7 Engineering economics and new ventures. Engineering economics is especially valuable in evaluating new ventures and projects. For example, when launching a startup, engineers must estimate market potential, development cost, production and distribution expenses, expected revenues and profits. Financial analysis determines whether the venture is viable and how investors will be repaid. In this first module, we have explored the meaning and role of engineering economics. We discussed its principles, applications, and decision-making frameworks. We highlighted the importance of life cycle thinking and the evaluation of costs and benefits in both established projects and new ventures. Next, we turn to Module 2, which focuses on engineering materials, the physical building blocks of engineering projects.